Hello students, welcome back. Let us continue learning networking concept. In the previous session, we had completed ISO OSI model. In today's session, we will be briefly seeing TCP IP, that is Transmission Control Protocol or Internet Protocol. Now, this is also another important topic. So one of these models usually gets asked in the examination. That's why please keep this in mind. All right, so let us directly dive into TCP IP. So TCP IP, just like our OSI model, this is also another model which is used in the networking. It is a layered set of protocol, and this protocol assumes that there is a way to communicate reliably between two computers. Okay, so mail, like other application protocols, simply defines a set of commands and messages to be sent. TCP is responsible for making sure that the command gets through to the other end. It keeps track of what is sent and retransmits anything that did not get through. Now, something similar even we had when it comes to the OSI model, where we had a different layers. Now, let us see what about the layers in TCP IP. So here also basically we are talking about a sender and there is a receiver and there are two nodes which is communicating through the network using this particular TCP IP. All right. So if you're talking about the layers, unlike OSI where we had 7 layers, in TCP IP we have only 4 layers. They are application layer, transport layer, network layer, and network interface. So as you can see, in each layer we use n number of different protocols. All right. Let us briefly see each one of these protocols. I would like all of you to write the expansions of that in your notebook. Okay. The very first one, if you have to consider file transfer, which is TFTP. TFTP is a protocol that transfers files between clients and servers without complex interactions. All right. So that is why TFTP is used. Next one is your FTP, that is your file transfer protocol, which is nothing but a protocol which is used in order to send, mainly because of mails. It will be used in mail transfers. That is why file transfer protocol. Your NFS, that is network file sharing protocol, that defines the way files are stored and retrieved from storage devices across the network. That is why network file sharing, NFS protocol. Next is your email, one more SMTP, that is Simple Mail Transfer Protocol, very famous protocol. It is an internet standard communication protocol for electronic mail transmission. And then you have SNMP, which stands for Simple Network Management Protocol. Is an application layer protocol that monitors and manages network devices using UDP. Now, what is this UDP? UDP is nothing but user datagram protocol. Next is our DNS, that is your domain name system. It is a TCP IP protocol that provides a mapping between host names and IP address. Now, what is an IP address? All of us have, usually we come across this IP address. For example, if you were to write google.com, okay, so this is actually a name, but the networking devices will not be able to recognize if you say Google. There will be something, for example, 192.2.5.6, something like that. Randomly, I'm giving this number. You would see something like this, 4 digits or 4 group of numbers with the dots separating them, 3 dots. This is called as your IP address. This IP address is also nothing but your logical address. Okay, now DNS, that is your domain name server, is the one which helps the networking device to convert whatever the higher level language address we have written into a machine level or into a proper address, into an IP address. Similarly, if there is an IP address, it is going to convert it into path. So DNS is the one protocol which we will be using in order to do all this conversion between IP addresses and the names. That is why it is domain name server. So these are the main protocols which we will be using in the TCP IP. All right, let us briefly see how the TCP IP works. So TCP/IP is the base communication protocol of the internet. The part of the TCP/IP uses numeric IP address, just like I told you, numeric IP addresses with the numbers as well as dots in between them to join network segments, and TCP part of the TCP/IP provides reliable delivery messages. Now, this reliable is what something which we have seen even when it comes to the OSI. So this model assumes that there are large number of independent networks connected together by gateways. The user should be able to access computers or other resources on any of these networks. So datagram will often pass through a dozen of different networks. So when I have a networks, there are network devices. So there will be different kinds of a network connected via different. So datagram can be passing through any of the dozens of different networks before getting the final destination. If this is a source and I have a receiver somewhere here, and if this is connected something like this, it can be coming from anywhere, isn't it? So the routing needed to accomplish this should be completely invisible. So user should not know when I'm sending a mail to any other person, I wouldn't know that how many network devices or networks it is passing through. So it should be invisible. So in order to access another system, this is an address that looks like this, that is 128.64.194.1. It is actually a 32-bit number. However, it is normally written as 4 decimal numbers, each representing 8 bits of address. So here each one will be 8-bit address if you're converting it into a binary number. Okay, so generally the structure of the address given to you some information about how to get to the system. We normally refer to systems by name rather than by internet address. That is what I said, Google. We do not say 192.128. We will say google.com. We will say Facebook. We do not know the exact IP address of those websites. So when we specify a name, the network software looks it up in a database and comes up with a corresponding internet address. So you do not have to remember that. That is done by internet itself. All right, each of these datagram is sent through the network individually. There are provisions to open connections. However, at some level, information from those connections is broken up into datagrams, and those datagrams are treated by the network are completely separate. All right. So the datagram gets transferred across the system in this way. So as you can see, these are the layers which we are having. So the application layer, it is responsible for user interface and application services, just like we had in our OSI, responsible for formatting messages for the transport layer. And after that application directly, we have a transport layer. The other two layers are having skipped here, or you can say it has been merged. So what does transport layer does? It ensures the data is delivered reliably and in order. So if at all I want to send A, B, C, D, this is the data. It should not go in B, C, D, A. So it doesn't make any sense, isn't it? So it has to go in the same order. That is also taken care by the transport layer. Internet layer, it provides IP addresses and routing. So IP address as well as routing. Here comes a new work. Okay. IP address, just like we discussed in the previous slide, that if there is a name, if at all I'm giving, it has to be converted into an IP address. And if at all there is an IP address, that name has to be found out. All this work is done by the internet layer. This is a new layer which has been introduced. Last layer is network access layer or link layer. Now this transmits raw data bits over physical medium. Now this work was done by the physical layer when it comes to the OSI model. So similarly, the bits transferring the bits over the physical media is done by the network access layer or link layer. And also it provides a MAC addressing and LLC. Now, what is this MAC addressing? Just like how we saw the logical address, MAC is nothing but your physical address of the system. So the expansion of MAC is media access control. So MAC address is the address of your hardware or your system. It is also called as a physical address. That is also done by your network access layer. So these are the 4 layers and their responsibilities. All right. So what is this? We spoke about the datagram. Now, what are these datagrams? Now, these datagrams are nothing but unit of data. Okay, just like we spoke about segments, packets, and frames in OSI. So here the datagram is a unit of data, which is what a protocol deals with. So all these protocols, what they're trying to do is they are trying to send the datagram over the network. So a packet is a physical thing appearing on the Ethernet or some wire. So when I talk about a packet, that is also a physical thing. Okay, packet is a physical thing which will be in your physical layer or it is getting transferred through the wire. So in most cases, a packet simply contains a datagram. So if I'm talking about a packet, it is contained in a datagram. So there is very little difference, however, they can differ at times. So you should remember the difference between a datagram as well as a packet. If we are to compare the OSI as well as the TCP/IP conceptual layers, so OSI has 7 layers and TCP/IP has 4 layers. So the application, presentation, and session together comprises the application layer of your TCP/IP. Transport layer remains same. Network layer remains same. Data link and physical is being clubbed together and it becomes a network access layer or your network interface. Now, this router is the device used at the network layer. Switch is a device used at the data link layer, and hub is the device used at the physical, especially when you're transferring the data, the wire connections is connected through the hub. All right. I hope this TCP/IP is clear. So that's all in today's session, students. Keep watching, keep learning. Thank you for watching.